So good morning, everyone. I'm here to talk to you about natural disasters, a really uplifting topic. Of course, after listening to what's been going on in this room for the last couple of hours, I think it is a relatively more uplifting topic. At least it's nobody doing it intentionally to us. But what I want to do is to help you come to an understanding, a different type of understanding of natural disasters and what they mean for our lives. And I want to begin from the place that natural disasters, natural hazards, are natural processes. I mean, as human beings, we need water. We need to live near rivers. That tends to be where we've put our communities. But every time you have a river like this, you sometimes have a river like this. Floods are an inevitable part of getting that water we need to live. And they're not the only natural hazard that are preferentially distributed where human beings have chosen to settle. You might think that we don't particularly want faults, but in fact, to have the San Francisco Bay, that harbor is created by the movement of two faults on each side of the bay, opening it up. Los Angeles is where it is because we came for the oil. The oil was trapped along the faults. The faults around here push up the mountains that trap the rain and keep us from being a complete desert without any life-sustaining water at all. And even volcanoes. Volcanoes produce incredible natural, nutrient-rich soil. And they are some of the best places to be growing crops. So human beings have, throughout history, tended to settle near volcanoes and faults and rivers and oceans, and we are then at risk from the natural hazards that are just a natural part of that process. And that process is fundamentally driven by heat. With rain and floods and hurricanes, it's about the water cycle. It's about the rain being, the water evaporating off the ocean, traveling over as clouds, coming back as rain. It's a redistribution of heat. And by the way, as our atmosphere gets warmer, we have more heat in the atmosphere. By definition, heat is energy, and there is now more energy going into storms. And we are already seeing and expect to see more increase in the intensity of storms because of the extra energy available. But geologic hazards are also about heat. Now, it's heat redistribution on a slower time scale. Where the water cycle is accomplished over a matter of days and weeks, the heat cycle in the Earth is accomplished over millennia and hundreds of millions of years. We have a hot interior of the Earth that continues to produce heat because of radioactive decay. That heat melts some rocks, and it comes up at the ocean ridges. It's magma coming up from the deeper in the Earth, hot magma, solidifying at the surface, then getting pushed out as more and more lava comes up, traveling around the world, and eventually going back down in subduction zones, but now as cold rock. So over 100 million years, we accomplish a cycle that helps to cool off the Earth. So everywhere that human beings have settled, pretty much, has natural disasters to worry about. Here in the Coachella Valley, for you, it's earthquakes. Without question, we don't really have to worry a whole lot about ice storms. You don't see a lot of hurricanes. Does occasionally get a few of them. You mostly appreciate the extra water. But here we've got the San Andreas Fault forms the eastern edge of the Coachella Valley. The western edge and those mountains are there because of the San Jacinto Fault. But the San Andreas is literally on the edge of the Coachella Basin. I'll tell you, geologists love to come out here because you can see everything so clearly. Here's one view on the eastern side, and that line going up across it. You can see the San Andreas. You can see it from the air. Go up the San Jacinto, the mountain tram. You can look out and see the San Andreas along the other side. And because the fault grinds up rocks, and makes them much finer grained, that makes them less permeable. It means that faults trap water and oil, as I said about Los Angeles. But in the desert, when you see oases, the Thousand Palms Oasis is the San Andreas Fault. Desert Hot Springs is the San Andreas Fault. And in fact, in Iran, essentially all of the traditional settlements are located on faults because that was the only place they had water out there in the desert. The point of this is, too, is that we know where the disasters are going to happen. Oh, I jumped ahead of myself. Let me just, how many of you have heard about the shakeout scenario? Shakeout drill? A few. Okay. A decade ago, when I was at the U.S. Geological Survey, we created a model of what the big San Andreas earthquake would be like, and went through in excruciating detail how many people we expected to die, what the shaking would be, what would happen to buildings. We worked here in Palm Springs, and you are seeing in this picture an animation of what we expect the ground motions to be. You see on the left, we have the fault and the map. Over here on the right, we are overlooking Palm Springs. You see PSP, that's Palm Springs. These are the ground motions that are going to be coming through here. The San Andreas is nearby, but you also have a big bowl of sediment, right? That's what the valley is loose dirt. And that when the waves come into that loose dirt, they slow down because it's loose. But to carry the same amount of energy, they then have to get bigger. So you get an amplification whenever you have loose soils, and it's about a factor of 5. What stronger shaking that will be experienced here in the Coachella Valley compared to being up in the hills just to the east of the valley. You have special problems with this. Notice I-10, and notice how the fault runs close to I-10. It will be broken in the south going out by, it's about down by Indio where it crosses. As you go north and into Los Angeles through the San Gorgonio Pass, the San Gorgonio Pass is there because the San Andreas Fault turns and runs through there, and the fault is actually rather zigzag in that location, and I-10 crosses it in a dozen locations over a distance of about 12 miles, and that will be completely impassable. It's going to take a long time to repair that road. So for you, you've got a special situation that you're likely to be isolated, you're likely to lose power, and in the summer, that is potentially life-threatening. So I can't tell you when, but we absolutely know where, and you need to be ready for it. We know where in essentially all of our disasters. This is what's called the National Seismic Hazard Map. It's compiled by the U.S. Geological Survey, takes all of the information that we have about where the faults are, what rate they have earthquakes, gives the rate at which you're likely to be experiencing strong shaking. And Coachella Valley hits the jackpot. You are one of the, you're the highest level in the United States. And for any one single earthquake, the southern San Andreas Fault here is considered the most likely source of a big earthquake in the United States. The problem is we don't know when, right? When you think about when should it be, what should be the distribution of events, we often think it should look like the left, what's called a normal distribution, that we have some time that it's going to happen, right? We say the earthquakes happen about once every 150 years on the southern San Andreas. So shouldn't 150 years after the last earthquake be the most likely, less likely before, less likely after, because that's the way we're used to it for weather prediction. You know, the storm's coming in tomorrow. It might travel a little slower, a little faster, and you get some slop, but it's a time in the future. So we tend to expect it to be this one, but it doesn't have to be, right? It could be that the time since the last earthquake doesn't really matter, because the process that gets an earthquake started isn't completely driven by the stress that's been built up. And then you would have a different type of distribution. We have some data that we can look at to show this. And here's what it looks like from a site in the San Andreas up near I-5. We dug into the fault, been able to find evidence of past earthquakes, carefully dated them with new carbon-14 techniques that are very accurate, and we can see the time between earthquakes. It averages 100 years on the northern part of the fault, or the central part of the fault. But 3 of them were less than 50 years apart, and 1 of them was more than 300 years apart. This is actually mathematically is best described by what's called a Poissonian distribution. It's also called a memoryless distribution, meaning the time since the last event doesn't matter. And that's probably the most likely form that this is taking, right? And we hate it. We do not handle randomness very well at all. Human beings are evolved to find patterns. Think about how we became who we are, right? Out in the savannah, against animals with stronger muscles and bigger teeth. Our advantage was our brain, our ability to form patterns to keep ourselves safe faced with danger. So that is a deep instinctual need in all human beings to find the pattern, especially when faced with danger. To be able to look at that grass and see the waving grass and hypothesize that it hit a predator kept us alive. To go and recognize the connection between the mushrooms you just ate and the gastrointestinal distress you're now suffering, that also was a way to keep us alive. People who made good patterns in the face of danger were more likely to have children. So we do it. The problem is we do it even when the patterns don't exist. Right? Think about constellations of stars. That's forming a pattern in a fundamentally random distribution. And we do this about disasters. They are fundamentally random. That means, one generation living on the slopes of Mount Vesuvius gets hit, another one's spared. We don't like to think it's just who knows, right? So we have long, over human history, created patterns to explain it. If you've ever thought about the word disaster, it was actually first used by Shakespeare. It means ill-starred. It reflects the belief that your fate is written in the stars and you get hit by the disaster because you had bad stars, because it was fate, it was somehow ordained. Right? And if you go to Rome, you would find that the explanation for the eruption of a volcano was that, if you remember, Venus married Vulcan, right? But she cheated on him. And when she cheated on him, he'd have a male hissy fit, and the volcano would erupt. And that was the standard explanation for why you had volcanic eruptions. So if you go and look at Mount Vesuvius, right, this is the current picture of Mount Vesuvius. That's Naples. Speak about putting yourself in danger. That's an interesting city. And when it erupted in AD 79, it erupted in what's called a Plinian eruption. This picture is actually from Alaska. We didn't have a camera back in AD 79. But this is a standard type of eruption in volcanoes where there's so much energy in the gas that it gets forced up into the air. And it's called Plinian because Pliny the Younger was living outside of Naples in AD 79, experienced the eruption, and wrote about it, and described this classic type of cloud. And when this erupted like this, people got scared, and most people got up and left. He has these descriptions of trying to get through the darkness. And he said, I was sure that my life was ending, but I took a small consolation in the fact that the rest of the world was dying with me. It really did seem like the end of the world. But most of them got away. Pliny got up to Rome, lived to write these letters to tell about what happened. After you sort of dissipate the energy in that explosion, then they start to come down. This is actually a picture from Mount Pinatubo. We didn't have palm trees there at Mount Vesuvius. But this is what's called a pyroclastic flow. And this is when those same gases now don't have the explosive energy pushing them up. They're heavier than regular air, and they start flowing down. And they travel at 30 to 50 miles an hour. I actually know somebody who was in a Jeep like that running away from Mount Pinatubo, and they could barely keep in front of the pyroclastic flow. Temperature of like 500 degrees, instant death when it hits you. And they think that that's what happened to the victims in Pompeii. A lot of people left, but there were other people who went, there's rocks falling out of the sky. I think I'm safer staying at home. And they stayed in their homes. Then the pyroclastic flow came through Pompeii, killing them instantly. And then actually the contorted positions are heat shock to the cadavers after the heat comes through. So I said the Romans blamed this on Vulcan's sunken pride, but there's an important lesson here for you, which is you're probably going to live. Even in Pompeii, 90% got out alive. When we have our big earthquake, you're probably not going to die. But you got to worry about living afterwards. And that's one of our really big messages. Okay? So, as I said, the Romans are blaming this on Vulcan, At the same time, the Judeo-Christian tradition said, no, God's good. God's somebody you can make a covenant with. If you got hit by a disaster, it must be your fault, because that would only explain how a good God could do it to you. So it was a standard part of the Western religious tradition that disasters represented God's punishment. And so much so that earthquakes were not researched, even as the beginning of Enlightenment and studying various types of scientific study with the Renaissance. Earthquakes were just God. You couldn't see them, you didn't know what was coming. And that was true until an earthquake hit Lisbon in 1755. Probably magnitude 8.7, created a tsunami, destroyed Lisbon. At the time, Lisbon was the fourth largest city of Europe. They were a major colonial power, fabulously wealthy from the gold and diamond mines they had in Brazil. This earthquake destroyed Lisbon, it burned down, and much of the country as well. But it also happened on the morning of All Saints' Day in a heavily Catholic, completely Catholic country that was in the middle of the Inquisition. At 9:40 in the morning, when most people were at Mass. Right? There were multiple Masses through the day, but the 9:30 service was completely packed and full. All of the churches collapsed. People died, almost everybody in the churches died. The candles fell off the altars, set off fires. The whorehouses that were up on the hill, away from the river sediments in wood-frame buildings, basically did okay. So we had a sort of fundamental theological issue that got raised. How can we explain all of this? And in fact, among the philosophers in the region or across Europe, it caused a huge debate. Voltaire was famous for writing the poem on the Lisbon disaster, less than a month after the earthquake. Can you then impute a sinful deed to babes who on their mother's bosoms bleed? How can you say that those innocent children were sinners? And he rejected the idea that God could be doing this as punishment. But that idea was so ingrained in Western society, he was then called an atheist. He wasn't, but he must be an atheist if he can't see that this earthquake was God's punishment. Rousseau argued against him, saying this was really the fault of people for making that decision to live in cities, right? Rousseau was pushing naturalism. And he also argued, well, we don't know what worse fate they might have escaped by dying now, which is like, whoa, how bad do you think a city is that this is the lesser fate? But among the regular people, you didn't see this. The Catholics just thought we haven't prosecuted enough Protestants, and they had more public burnings and autos de fe. The Protestants went, what more evidence do we need that the Inquisition is the devil's work? And in fact, the Calvinist Dutch government was asked for aid for Lisbon, and their response was, God has decreed how much Lisbon should suffer, and it is not our place to change what God has decreed. And they refused all aid. Now, you might think, boy, we look pretty bad here. In fact, the same ideas are going on in the East as well. So when the earthquake happened in Tokyo in 1923, it was actually literally under the city of Tokyo. It wasn't a vertical fault, it was a dipping fault. And so all of Tokyo and Yokohama sat on that fault. 140,000 people died. 60% of the buildings in Tokyo and 80% in Yokohama were destroyed by the event. And in fact, one victim was quoted as saying, if this were not hell, where would hell be? Right? But to the Japanese, they don't have the Christian tradition, but they had a Confucian tradition. And the Confucian tradition said that the emperor is the mediator between heaven and earth. He sits at the interface, and problems in court will be reflected in problems in the natural world. So everything was about harmony and yin-yang balance. And if the emperor was weak, that meant the yang, the male force was weak, the female force would get too strong, the earth would overpower the sky. If the emperor were too autocratic, you get hurricanes as the sky overpowers the earth. But for them, this meant that the emperor was going to die, was the most likely reason for a big earthquake. And in fact, the emperor was so sick at the time, he hadn't been seen in public for several years. His son was acting as Prince Regent, and the prime minister, also a major yang force in the government, had died from natural causes the week before the earthquake. So even though in Japan at this point they were transitioning into a much more modern society, every tradition said this is the fault of the government. And the turmoil that developed between that traditional look and what was going on turned into a pretty horrible result, which was they turned on their Korean neighbors. And 6,000 Koreans were slaughtered by their neighbors in the next 4 days. Right? And it took on an aspect of ritual torture, of like expiating the sins of society to bring back the balance that was needed. And you could say, okay, that's Japan, but no, it's human nature. Our most constant response to disasters is to find somebody to blame. Now we tend to do it on FEMA, right? But every one of us and in these situations, we try to find somebody to blame, and it can bring out the worst in us. It can also bring out the best. And if we go back to Portugal, the prime minister at the time was the Marquês de Pombal. And he apparently did a fantastic job of responding to this. He went to the king, who had been out of the city when it happened. The king, what do I do? And he replied, at least the story goes, "Sire, we bury the dead and feed the living." Which to me is the most succinct statement of emergency management I've ever heard. It's still true. What do you have to do? He went out and did it. He got things organized. He did it so successfully. He got plans for rebuilding Lisbon in front of the king within 1 month. They had completely cleared out the debris and restarting construction in less than a year. He created a style of buildings that's called Pombaline in his honor, where they made scale models of the buildings and ran the cavalry around the scale models to test how the shaking would affect the buildings. So it's the first earthquake engineering. And he really brought the community back. I mean, I talked about how they never became the great colonial power they'd been before, but they recovered. And a lot because of him, and he gained great political clout out of it, and in fact used it to get the Jesuits out of Portugal and ended the Inquisition. So this is another lesson for us. Again, don't worry so much about dying in the earthquake. Worry about living afterwards. And what is recovery going to be like? Well, what do I mean by recovery? I'm not going to give you a lot of graphs, but I'm going to put in this one. What is recovery? We expect our economy to be gradually growing with time. This is, time, economic activity, all the things you own and all the things that are making and going on as our economy develops. When a disaster happens, we lose, things are broken, and the economy shuts down. People can't go to work. We don't have power. We don't have water. We don't have sewer, transportation. What we're trying to do is to get back to where we were as quickly as possible. And it often does happen this way. We sometimes call this the Northridge model. LA was actually in a recession when that earthquake hit. We had so much money pouring in. We had a really proactive FEMA. 40% of people had earthquake insurance. People hired contractors. They hired subcontractors. And it not just got the economy going again, it got us out of the recession. But it doesn't have to happen that way. If you can't get things going quickly enough, you can end up with a long-term decay in the economic activity of the region. And just compare the areas under these curves, and you realize that the amount of money to be lost in a delayed recovery can dwarf what happens in the disaster itself. So it's recovery is what really matters. And if you think this is really hypothetical, let's look at the GDP of New Orleans through the time of Hurricane Katrina. Comparing it to Nashville, which is a similar-sized city, not too far away. And you can see, even though $80 billion was lost at the time of the hurricane in 2005, the lost GDP in the next 7 years, just by assuming they should have been able to keep up with Nashville, is $105 billion. And this isn't just money, it's people. This is the population of New Orleans over this time period. People left and they didn't come back. And the city is just never going to be what it was. Now, yeah, they went from 500,000 people to about 350,000 people in the long term. Wow. Right? So what do we do about that here? And I think when we look at it, we need to recognize that it's our urban society that's in risk. Right? And what we are trying to do is have a community that still functions afterwards. What's necessary to do that? Let's look at what a city is. We call a city a system of systems because we start with a system of pipes, water pipes and sewer pipes. And on that, we build the houses that we live in, the buildings that we work in, our manufacturing centers, our power systems, our transportation systems, our communication systems. And all of these systems work together to make urban life possible. And they are based on a set of critical infrastructure. Right? You heard Errol Southers this morning talking about critical infrastructure and the worry about what it takes against the people who could destroy it. We've actually been able to partner with them and use the same methodology to look what happens with the natural disasters. And we can define a set of critical infrastructure that's absolutely necessary to keep a city moving. And that's water, power, communication, because in our modern world, you can't keep a business open without communication, and buildings to live in. And we need to keep these functioning well enough that we can then build all of the other parts of modern life which depend upon this critical infrastructure. Now, we don't have to keep them working perfectly. Let's imagine that we lose some buildings, but we still have internet. Well, people can now telecommute, and they can keep their jobs going even though they don't have the buildings. Or we lose water, but we have transportation. We can bring water in. And these work for a while. You know, FEMA has plans for bringing water in here. But how many of you are going to stay here when you haven't had a shower in a month? And your neighbor hasn't had a shower in a month? That's one of the really big issues, and it's a really big public health potential nightmare. So we have to get the systems able to be repairable. So how do we get this? What are the main things that matter? The biggest one, and I always push this, is why not have something that doesn't get damaged in the first place? It is possible to build things that don't get damaged in earthquakes. And the more we're willing to do that, the less need we have for response. The other thing is planning makes all the difference. I love the quote from Dwight Eisenhower, who said that plans are useless, but planning is essential. What happens in that event will not be what you planned for, but if you have planned, if you are working together. And you know, a lot of our messaging about earthquakes tends to be isolating. You're going to be alone. Nobody's going to be able to respond. You need to be ready to take care of your family. That's a potentially isolating message, that your neighbor is your potential enemy. Well, that's a self-fulfilling prophecy. I think if we can make our neighbors our colleagues, the people that do help us, the people who do come together with the event, then we have a much better chance of getting through it. And also, the better job we can do at responding means the shorter the job we have in recovery. To do this, we need to be engaged. And I look back at an earlier eruption, an earlier disaster, the eruption of the Laki craters in Iceland in 1783. This is potentially the biggest disaster, deadliest catastrophe in human history. I mean, there were only 50,000 people in Iceland, and about a quarter of them died in the event, not from the lava hitting them, but from the gases that came out with the lava. But those gases also got up into the stratosphere, moved out across the world, cooled off the world, reduced the global temperature for the next year, caused a famine in France that helped contribute to the French Revolution, caused a famine in Egypt because the Nile didn't flood. They lost a sixth of their population. They caused a famine. It was contributed to a famine in India and in Japan, where about 11 million people died, all told, between those two countries. So you can say it's the worst, the deadliest disaster in human history, but not because of its local effects. It's because of its global effects. Locally, if you grow up in Iceland, you hear all about someone that's called the fire priest, Jon Steingrímsson. And Jon Steingrímsson was the pastor for one of the communities that was threatened by the lava. The lava was heading to town. They had one last service in their church to talk about it. He apparently preached a quite long sermon. And by the end of it, the lava had stopped moving. Now, actually, we look back and we think that it ran into a river that had enough water in it to freeze a dam and divert the lava before the river completely evaporated. But he's called the fire priest, the one who preached a sermon that stopped the lava in its tracks. The reality is he spent the next year and a half helping his community get back together. He got out there and brought them medical supplies. He went to Reykjavik and brought in aid for them. He led a big team down to the coast. All of the land-based food was poisoned by the fluorine. The animals had all died. If you tried to eat those dead animals, you died from the fluorine poisoning. So all the crops, all of the fish in streams were poisonous. You had to go to the ocean to get food. He led a team out there, and they actually found a a big colony of seals that they were able to kill and bring back enough meat to keep them alive. And so if you look at his whole story, what he did was keep the community together and, and make them be able to recover. And they came back from this. But he's remembered as the fire priest, as the response. And that tells us something about human nature. We focus on that moment and we forget about the recovery. But it's the recovery that's more important. And it's people who will determine what happens. So what are you going to do? I'm not going to try to tell you what to do. If you want to know, I'll send you to earthquakecountry.org. There's a lot of direct things that are in there. And I can tell you what I've done. I worked for the federal government, the U.S. Geological Survey, for 33 years. I retired a couple of years ago to be able to focus more on working with communities, understanding the science. And one of the things I'm doing, I've been working with SCAG, helping communities that want to engage in mitigation, that want to bring in retrofitting of bad buildings. Your building's only as good as the building code that was in place when it was built and the degree to which it is enforced. So you can probably get a stronger building, and there's some known really deadly ones out there. Los Angeles, Santa Monica, Moore Park, and West Hollywood have all enacted mandatory retrofits of some of these really bad buildings. And there's another dozen cities that are working on it right now. As a resident of Pasadena, I am proud to say that we are voting on it this month. But so also, Beverly Hills has already passed. Long Beach is working on it. Culver City is working on it. There's a lot of places that are, and it's been really exciting to watch that happen. I'm also trying to develop programs for community organizations, because if we're going to stay because of people we care about, those are the people we know through our churches, through our schools, through our synagogues. And those organizations, if they're stronger and still here and functioning, they're going to be able to support their members and keep the community together. And I'm also, this is one of the most exciting things for me because I am still a scientist. I'm working with scientists at Caltech to help train them on how to work with policymakers. Because the reality is, we work in pretty different worlds, and teaching scientists how to talk with policymakers is a I tried to do it in 1 week. We decided it needs a whole quarter class. Let me finish with a really inspiring example, and that's from the Tohoku earthquake that hit Japan in 2011. You might wonder why I say that I'm really inspired by it. Well, one thing is they had a magnitude 9 that killed only less than 150 people. And there is an answer. You can build to withstand the earthquakes. Building a building 50% stronger than what our code requires would add about 1% to the cost of construction. And our code is solely life safety, crawl out alive. In Japan, they're aiming for reusable buildings. And they've done it, and people aren't dying in those events. But of course, with that event, it triggered a tsunami. The tsunami was much larger than was thought possible. It overwhelmed their defenses, killed about 18,000 people, concentrated in the small coastal towns. So these small rural towns with maybe 10, 20, 30,000 people lost 10, 15% of their population in the event. And they are really struggling to recover. They invited me over there, and I got to meet women who were involved in trying to rebuild their communities. And one of the most positive things I saw was the opportunities that were opening up. These women are living in a very traditional part of Japan, where they really had very few options. It was you marry and you live with your husband's parents till they're dead, and since people are living to 95, you're there living with your in-laws till you're 70, and it's not a really thrilling life. And a lot of people were leaving. The tsunami was so disruptive to the communities is that it opened up opportunities. And I was invited there by a group that's supporting women entrepreneurs. And I'm like, women entrepreneurs in Tohoku? But they're doing it. One of them is this Shinto priestess in the black coat. And her shrine had been damaged in a 1960 tsunami that came from a Chilean earthquake. And they had literally taken the old shrine and moved it up the hill to get out of the tsunami zone. And it was high enough up the hill, it didn't get hit by this tsunami, but her house was completely destroyed. She lived in temporary housing for the next 5 years. Right? She had just gotten back, and she started what she's called the Camellia Project, because it turns out that back in 871 AD, there had been an earthquake with a really big tsunami. And there were plinths that they were able to find that basically say, come here. they were messages left from that generation. This is where you need to go. But the information had been lost over the 1,000 years. So her camellia project is to bring the community together and plant a path of camellias to the place of safety. And camellias have to be maintained. So generation after generation, they're going to be teaching children to take care of these camellias and know and try to save that information about where to go. That shouldn't have been in there. Okay. The other thing I wanted to talk about here, this is the town of Otsuchi. This was their city hall. And they had policies that said, after a big earthquake, go up the mountain. But there was then a warning that there could be a 5-meter tsunami. And they knew they had a 6-meter seawall. So they stayed in their city hall. And the whole city council was meeting there. When the 14-meter tsunami came through, their whole city council was lost, as well as a lot of the village elders who were waiting outside to hear what they were going to be saying. And this is a community that is struggling more than any other to recover, because they lost all of their leadership. But they are coming back. And one of the women I met, her name is Mio Kamatani. She had actually come in as an emergency nurse, ended up falling in love with somebody and staying, and has helped leading a group that's rebuilding the community, trying to find what matters to them, how to re-engage with the federal government, and to learn the lesson, don't be too dependent on the scientists. Don't believe everything. We do our best, but we have errors, and we can't be taken as absolute. Right? And of course, in Tohoku, I think you all know, what really turned it from disaster to catastrophe was the damage to the Fukushima Daiichi power plant. And when that was, and they did almost everything right. The plant had no trouble with the earthquake. The plant was above the level of the tsunami. The backup generator's fuel supply was stored too low down and was washed away in the tsunami, so they no longer had backup power to run the cooling. The plant melted, the fuel ended up melting, and they had to start evacuating. And it started with a first 2-kilometer radius, then a 5-kilometer radius, then 10, then 20. And they went out to Fukushima. And the city of Fukushima is right here. And you see, it's actually rather a hot spot, but it was outside the evacuation zone. And people were evacuated from there into temporary housing in Tohoku, or in Fukushima. And this is one of my next lessons. Don't forget that it's cascading failures. We can't predict everything that's going to happen. We need flexibility as we go to respond. And it won't be the earthquake itself. It'll be perhaps the loss of power and all the people who die because there isn't sufficient air conditioning and you can't get out of the valley and the earthquake happens in July. That's one of the things that you guys really need to be ready for. The people were brought out to this refugee housing, many of them wearing only the clothes off on their backs because they were rushed out of their homes. And they came in here and were monitored for radiation exposure, and some of them had the clothes off their backs taken away because there was too much radiation in there. And for the people who lived in Fukushima, they were not told. They only found out about the problem when the refugees started arriving. This woman is named Maki Sahara. She was a housewife, getting ready for her daughter's preschool graduation as the earthquake hit. And she was outraged at what the government wasn't telling them. And she ended up going from being a stay-at-home housewife to the leader of an organization demanding information for being able to cope with the radiation. Those green sheets that you see, that's all of the topsoil for the city of Fukushima, scooped up, the top 2 inches with all of the cesium and other minerals that had been deposited in it, scooped up, brought over here, and taken out of the city that way, and she made sure that they got radiation monitors in front of it so that they could tell whether or not it was becoming unsafe again. She got radiation monitors put in the parks. They had to teach their children to play on the concrete, not in the grass, because the cesium would get deposited in the spaces within the grass, and it was more dangerous. She got handheld Geiger counters and taught the children how to use them so that they could recognize for themselves, to empower them to be safe and to take control of the situation. And I found what she did just incredibly inspiring. And, you know, the thing she said to me was, I asked her what she wanted to tell the world about this. And she told me, I want to look back in 20 years and know that we did too much to help the children. Because to look back and know we didn't do enough would be unbearable. And I think that's the message for us as we get ready for the earthquake. It's inevitable. We don't know when it's going to be. I hope we do too much to keep our communities safe, and instead of not enough, because what really is at stake is not our individual lives. It really is our communities, and we're all in this together. Thank you. Okay, so I did manage, we have 3.5 minutes if you want some questions. Yes? Go ahead.
In my house, in an inner closet.
All right, sure. I'll repeat it.
In my house,
Yeah.
in the inner closet,
Yeah.
I have a large container of water.
Okay, you're talking about the large container of water.
Yeah.
Uh-huh.
I've had it about 8 years.
Okay.
Is it time to throw it out?
Yes, you should be replacing your water storage once a year if you've just got the big container of it. There are ways of keeping water that are last longer, but they tend to be very expensive. And anything you could do, when we look at the problems in the big San Andreas earthquake, I say however much water you have, get some more, because that's going to be our biggest problem. One more question. Yeah, I guess we could have 2 questions probably.
Based on what you're predicting, are there going to be any warning signs, or are the animals going to act weird?
Okay, so what warnings could there be for an earthquake? Seeing the animal warnings is a case of refusing to accept random and creating patterns when they aren't there. Anytime we've been able to actually control about animals, it doesn't work. People want it to be true, so I have seen an appalling number of even school textbooks that talk about animal warnings, and it's completely not true. You don't want a prediction of every earthquake. You want a prediction of which of the tens of thousands we have every year in California is going to be the one big enough to do damage. So we're wanting to predict the magnitude of the earthquake. The problem is the difference between a big and a small earthquake is not in how they start, it's in how they stop. You start ripping down the fault, and if it stops after the length of this room, you've got a magnitude 2, 2.5. If it goes 200 miles, you have the magnitude 7.5. So it's where is it going to stop? And right now, so we haven't ever seen a signal that works. If we can prove that the Earth doesn't know how big the earthquake's going to be before it begins, if it is determined dynamically during the earthquake, then prediction is impossible. We have not yet come to consensus on that in the community. I think the evidence that it's fundamentally unpredictable is pretty strong. I think that's the way it's going to go. One more question.
We've had several disastrous fires in California near us, so I feel so bad for them that lost everything. We can send money, but is there anything else that we should do?
Okay, so how do we deal with fires? Deal with climate change. The reality is the climate is changing. It's becoming drier. It's becoming warmer. And because of that, our trees, wherever they are, were evolved for a cooler, wetter system, and therefore they're more susceptible to fire. So on the long run, that's the biggest thing. They are going to be increasing. Right? The idea that you can take care of this with thinning out the forest is wishful thinking. Many of our most devastating fires are not even in conifer forests, and in chaparral systems. The time since the last fire really doesn't matter. It only matters in conifer forests and deciduous forests, but California's only got the conifers. But I think the other thing we can do is to build more compactly and not try to live in the wildland-urban interface and monitor it better. That will do a better job of it. And they're going to cut off my mic in 7 seconds. Thank you.